So in this discussion, we are looking at an example of simple harmonic motion. So the piston of a steam engine moves with a simple harmonic motion. The crank rotates at 120 RPM and the stroke length is 2 meters. Find the velocity and acceleration of the piston when it is at a distance of 0.75 meters from the center. So we are looking at the acceleration, okay? What will be the acceleration, okay, when y is 0.75 meters? That will be the displacement. The distance from the center is going to always be the displacement. So we don't know the omega, so we are going to start by looking for omega. So first of all, we are seeing that n, which is 120 rpm, okay, we can take it in radians per second, okay. We're going to look at it in radians per second. So radians per second here, because that's the speed at which the crank is rotating. So we are saying this is going to be, first of all, we know that this is like in one revolution, we have 2 pi. What about, we have 2 pi radians. What about 120 revolutions per minute? So we will have something like 2 pi out of 60. So this is going to be 2 pi n out of 60 radians per second. In other words, how you can understand it, remember we are saying that for one revolution corresponds to 2 pi radians. What about 120 revolutions? These are going to be 2 pi times 120, okay? But then this is per minute. So in 1 minute, okay, 1 minute, we are having 2 pi times 120 revolutions. These are radians, okay? These are radians. We have those radians. What about the 60 seconds? Because this is 1 minute, which is equivalent to 60 seconds. So instead, this is going to be 2 pi times 120 divided by 60. So now that is in 1 minute. So meaning that 120 rpm is equivalent to 2 pi times 120 divided by 60 radians per second. So from today and onwards, when given what we call the RPM, the speed in revolutions per minute, so the radians per second that we always want will always be 2 pi n divided by 60, whereby this is the speed in RPM, meaning revolutions per minute. Now, we are looking at, first of all, a shaft, a crankshaft, a crank, which is part of an engine, okay, that is rotating or moving at that speed. So it is moving at a speed of 120 revolutions per minute. Now, let's look for our omega. Okay, we have now seen that our omega is of that nature. So our omega is equal to 2 pi times 120 divided by 60. Maybe we can calculate that. So 120. So this is 2 or 4 times pi. And this is 4 pi radians per second. So we want to look for the velocity and acceleration. So first of all, velocity v is equal to omega r squared minus y squared. So we have to understand that. Then what is R? So remember, this is, you have an engine, okay? An engine, they are saying that the stroke length of an engine is the distance it moves from the bottom dead center to the top dead center. So when it moves from the bottom dead center to this is the extreme position down, this is the extreme position up. So meaning this is going to be 2r. That is going to be the length of this stroke is going to be 2r, because this piston is vibrating to and fro between the top dead center and the bottom dead center. So this 2r is equal to 2, and therefore r is equal to 1 meter, because we are told that the stroke length is 2 meters. So the velocity, having obtained r, we know omega, so we can proceed and look for y. So this v is equal to omega, we already know it as 4 pi, then square root of r squared, it is 1 squared minus y squared. What is y? Do we know it? Find the velocity and acceleration of the piston when it is at a distance of 0.75. So y, the y is, so y is also 0.75. So we put our 0.75 squared. So 1 minus 0.75 squared, I take the root of that, I multiply by 4 pi. So v, the velocity is going to be 8.31 meters per second. Let's look at acceleration. Acceleration is omega squared times y. So this is 4 pi everything squared times 0.75. So 4 pi, we multiply by 0.75. So the acceleration, eventually it is going to be 118.43 meters per second squared. So that's how we can get the solution to this problem. We have obtained the velocity and acceleration of the piston at a distance of 0.75 meters. So what you have to understand from this is how to substitute in this equation for velocity and acceleration. For velocity, you must get r, you must get, for y you have, but how to get this omega. Omega, we said, is coming from the RPM, so you only need to change that RPM to radians per second. And when you change it to radians per second, that will become your angular velocity. Substitute it in there, get your velocity. Then the formula for acceleration is omega squared y. So you put in your y and get the acceleration. That will be the end.